from here, we're going to use this picture to prove one more theorem, okay? So they didn't tell us the given and the proof statements. We have to figure that out from what we're given, okay? From the picture. So first off, we can see we have two triangles, and angle A is congruent to angle D, so that's given. So we'll say angle A is congruent to angle D. We're also given that angle B is congruent to angle E. We're trying to prove the third angles theorem, which would be that if two angles of one triangle are congruent to two angles of another, the third angles are congruent. So our goal is to prove that angle C is congruent to angle F. Okay? I would encourage you to try and see if you can figure this out on your own before we go through it. Just write in pencil so that you can erase later. So our first statement, now that you've already worked it yourself, you can compare with me. We have angle A is congruent to angle D because of given, and our picture's already marked. Then we have angle B is congruent to angle E, again given, and our picture's already marked. Well, from here, we know that all the angles of a triangle add up to 180 degrees. So I'm going to go ahead and say that the measure of angle A plus the measure of angle B plus the measure of angle C equals 180. And that's our triangle sum theorem. Well, it's the same thing for the other triangle, so I can also say measure of angle D plus measure of angle E plus measure of angle F equals 180 degrees. Again, by the triangle sum theorem. Now, I also can see that if both angles add up to 180 degrees, then they have to equal each other. So if A plus B plus C equals 180, and 180 equals D plus E plus F, then by transitive property, you know that those two are congruent to each other, okay? Since this is equals, you could use transitive property of equality or substitution. So we could say measure of angle A plus measure of angle B plus measure of angle C equals measure of angle D plus measure of angle E plus measure of angle F. Well, from here, we know that A and D are congruent, so they're the same thing, but we can't replace it. We can't say that they're the same thing from congruence to equal, so we need to convert it. So I'm going to go ahead and say measure of angle A equals the measure of angle D by definition of congruent angles. I'm going to do the same thing with B and E. Measure of angle B equals measure of angle E by definition of congruent angles. Now I can replace. If they're the same, then I could say then this A and B is the same thing as that D and E, right? So if those are the same thing, couldn't you subtract this from both sides of the equation? They're the exact same thing. Could you then also subtract B and E? Those are the exact same thing, okay? So if you took those out of the equation, you're left with the measure of angle C equals the measure of angle F by subtraction property of equality. Now, if they equal each other, our goal was to prove them congruent, then we know that angle C is congruent to angle F by the definition of congruent angles. And so now you've just proved the third angle theorem, which you can now use, that tells you if two angles of one triangle are congruent to two angles of another, then the third angles are automatically congruent. Okay? So that's your third angle theorem. It does not prove that the triangles themselves are congruent, because you could have an equilateral triangle, for example, that, let's say you have this triangle. All of its angles are the same. Then you could take another triangle, and all of its angles are the same, but it's twice as big, okay? So the angles are all the same, but the triangles are not necessarily congruent.